Continuing on with Chapter 6. This is a picture of an experimental setup and some data from the Dada and Dayo study that's mentioned in your book on page 136. Now, this was a very interesting study. What the subjects did was they were instructed to look at the center of this stimulus, and this was an ambiguous stimulus that had all these different grates on it, right? And they were instructed to keep their focus of their vision right there in dead center. But as they were staring at that dead center, to change their attention to different spots on this thing. So while you're still looking, focus your attention on this one, right? Don't look at it, but focus your attention on it. Then focus your attention on this one. Again, don't look at it, but just focus your attention on it. And what they found is they were able to track changes in the receptive field inside the brain every time the focus changed. So even though the eye was not changing the stimulus that was going into the brain, just by virtue of the fact that you were changing attention, going back and forth between all these different areas, meant that we could actually record changes in the brain of changes in the receptive field. So if I was looking at area 1, for example, which would be this one right here, it would the brain would light up like this. Area 2 would light up like this, all the way to area 6, which is this one here, which lights up like this. So they had just a really amazing finding that just attention, and not simply the stimuli that come out of our eyes, is partially responsible for altering which receptive fields we're focusing on, right? There was another study by Wallensdorf and Anton where they looked at brain changes in monkeys, right? So the monkeys were trained to either focus on this little diamond or this little circle. And whenever they were trained to focus on this diamond, this receptive area lit up in the brain. But as they were trained to change their focus to the circle, the receptive area moved. It actually moved from the diamond over to the circle. Now, bear in mind that this second stimulus, S2, and this stimulus here, the monkeys were looking, like the humans, the monkeys were focused on a specific spot and were simply being trained to focus their attention back and forth between different stimuli. And we were able to detect changes in their brain based on the change in their focus, right? So what happens when we don't pay attention to something? Can we still perceive and process things when we don't focus our attention, right? So this has been an area of study for a very long time. We have this phenomenon called inattentional blindness, where a stimulus is not perceived even when a person is looking directly at it, right? So you've probably had this happen to you before, right? Where this happens to me all the time, where you're looking for somebody in a crowd and you're like you're scanning the whole crowd and they're like right in front of you and you don't see them, right? But there are a lot of things that do pass into our field of vision, right? And we don't notice them, right? We just don't process them, right? So, for example, there was a experiment done by Simons and Chabris where basically they were showing people, teams passing basketballs back and forth, right? And the subjects were told to watch this video of these people passing a basketball and to count how many passes were being done, right? And as they were doing this, the video had a person in a gorilla suit just like walk across the court, right? Like right in front of right through the teams that were passing the basketball. And it turns out that almost half of the observers that were counting passes didn't even notice the woman with the umbrella or a gorilla walking through the field. This is an image from a Lavie study in 2010, so it's a fairly recent study. What they did to each of the subjects was they would present these crosses that you see here. These crosses would be presented for 5 trials 1 through 5, so 5 times. And each time the crosses were presented, the subjects were asked to tell which of the arms of the cross was the longest. Was it the vertical one, which in this example is the blue, or the horizontal one, which in this example is green? And that was their job, right? Look at this picture and tell me which one is long. And then on the sixth trial, they got the cross again and said, tell me which one's the longest. But at the same time, they were presented with this little box up here in one of the corners. And then they would do the task and then move on. The dependent variable was, did the subjects perceive this little box? So while they were paying attention to this task, did the subjects perceive this box, this little stimulus that appeared in one of the corners? And again, about half of them did not. Half of them did not perceive that stimulus while they were paying attention, but some of them did. About half of them did actually perceive that stimulus. This is a picture from your book of the gorilla thing, right? So these people are like doing this task, and your job is to watch them do this task. And then the gorilla like appears and does a little dance and then disappears. And about half of the people that were watching this video didn't perceive the gorilla. The other thing that we're not very good at is detecting changes in a scene. So for example, I can show you a picture, and let me show you real quick. So here's this picture out of your book, right? There's these people that are at a market, and there's this picture that's before, and then there's after. And what your task is to identify what the different changes are in these pictures. And one of the easy changes that I can see is that this sign here, there's a sign that's here that changes colors. And there's probably a few other changes, but we're not very good at this. It turns out that you have to change a picture a lot. Well, at least make several changes at the same time before somebody perceives changes. If you add a cue to have subjects focus on a specific area, that helps. They will notice the changes more quickly. But in general, it takes several changes before anyone notices changes. And you've probably experienced this in your life as well. For example, when you're if you've like made a change to your hair or gotten new glasses or something like that, and you've noticed that people don't notice because that's just the way people are. We're not very good at detecting changes. Change blindness also occurs in film shots. Any Hollywood production film has continuity errors where props are moved and costumes are different from scene to scene to scene. Most people do not detect these changes. We don't associate randomly moving objects back and forth with our reality, because the only way things change in real life is if there's some action done on them. So if a movie is going from shot to shot to shot, and there's like a prop or something that appears in one shot in one position, and then in another shot in another position, and then it moves back to the original position, we're probably not going to detect that, only because there wasn't any sort of action applied to that object to make it move. It's just it just got moved because of it was a mistake that was not caught in the production of the film. There's an example in your textbook on page 139 of some scenes from some video. I don't know what this video is. It looks like a very boring video. But you'll see this original shot here. You'll notice the woman is wearing a scarf in this scene, and then it's gone in this scene. And then it reappears again in this scene. And it's in this scene, but in this scene, the plates are different. The plates are white instead of red. And people don't notice these things only because of the fact that, again, we associate changing objects with some sort of actions. And in the course of watching a movie, watching this story unfold, there's no actions that were applied to moving these plates in the movie. We're focused more on the facial expressions and body language and actions of the actors themselves in a movie. Lee did an experiment fairly recently in 2002 where observers were asked to perform one of three tasks. And let me just go ahead and show the task to you here. Basically, what they were asked to do was to focus on this cross. So that's their starting focal point. And then letters would be flashed, and their task was to determine whether or not all the letters were the same or different. So different letters would get flashed here, and same or different, same or different, same or different. And that was the one group that was doing the central task. Another group was asked to do the same task, but while they're doing it, to focus or to also see and identify the scenes that appeared in images off the center. So while they're doing this task, scenes would appear here, and later on they were asked, did you see that scene? And then the third group was asked to do that as well, or I'm sorry, to do look at different discs, to look at different colored discs, whether or not the disc appeared and what colors or what color it was. Right. So there's three groups. You're either just doing this by itself, doing this plus looking at scenes, or doing this and looking at different color discs. Later, when we asked the people, or when Lee asked the people, did you see the scenes during your task? Virtually all of the scenes were correctly identified. But when we asked, did you see this particular color combination while you're doing this task, it was almost chance levels. What this tells us is that even when we're not focused 100% of our attention, we still are able to process some aspects of a scene, some aspects of something that we can attach some semantic meaning to. This has nothing that we can associate with. We can't chunk this into anything convenient. But we can remember if we've seen a particular scene or even a particular face. Foster and Lavie. This study is reported in your textbook on page, on the bottom of page 141. Okay. And basically, what they were asked to do was essentially they were trying to see, okay, we've got this perceptual capacity and we've got this attention capacity. Okay, what are the limits, right? How much can we load perception and attention before we start making mistakes, right? So they had these folks do this task. And the task they did was, they had two different tasks, an easy task and a hard task. The easy task was to identify a letter in this little array, and they made it either easy or hard. So for example, if I were to ask you, do you see the letter N in this array? That's very easy, and you'll respond very quickly. But if I were to ask you, do you see the letter X in this array? It will take you longer to respond, and it is a harder task. Now, we had another group that had the same task, except they had a cartoon character, right? A cartoon character that was flashed in both tasks, on the easy task and the hard task. All right. And what they found was that and it was just like this little cartoon character that would pop up and distract you, and while you're, quickly while you're trying to do the task. And what they found was that the cartoon character had a very minimal effect on the hard task. So we had our attention focused on this, right? And there was no extra attention that could be devoted to anything else. So essentially, this extra stimulus that was presented during the experiment was ignored. It didn't really have much of an effect on the responding and the ability to do this task. However, with the easy task, this is a very easy task to do. We don't need all of our attention to do it. And as a result, we had some attention to spare when this distracting stimulus is presented to the subject. This slide here illustrates this principle pretty well. During the easy task, during the performance of the easy task, we're not using all of our perceptual capacity. We're only using a little bit of it, represented here by the green filling. We still have a lot left that we can use, and that's what we're using to shift our attention to this cartoon character that appears while we're doing the easy task. However, while we are doing the not easy task, the hard task, we don't have any perceptual capacity left. There is nothing left that we can use to shift our attention to that cartoon character. You've done this before in your own life. Have you ever been driving, and whenever you're driving through some place that you're very familiar with, you can have the radio on and be talking to people. But then you get into some situation where the driving gets more complex, and what do? You turn the radio down. Right? It's like, the driving is difficult, I need to turn the radio down. That's because you need to focus your attention. You can't focus on the radio anymore. You've got to focus all of your attention on the more difficult task that is before you.